These trinomials have a leading first term that is a square, a middle term that is linear, and a third term that could also be squared, but doesn't have to be. First, we'll keep it simple by using 1 as the only leading coefficient for the first term. A trinomial with a leading coefficient of 1 is factored by creating two binomials in parentheses and determining the correct addition or subtraction, because we want to match the middle term, of the products of the two inside and two outside values that form the two binomials. It sounds complicated, but you'll understand it fast enough. For example, factor the trinomial x squared plus 7x plus 12. First, we set up two sets of parentheses like before. Because we are limiting these trinomials to a leading coefficient of 1, the first two terms in the parentheses must be x, because the leading term of the trinomial is x squared. Now, to determine which two numbers complete the two binomials, we have to ask ourselves, which two integers, when multiplied, give a product of 12, and when added, a sum of 7? 7 is the middle linear term, and 12 the last term. There are only three possible multiplications that yield a 12. 4 times 3, 6 times 2, and 12 times 1. Of these three, the correct sum is the one that adds up to 3 plus 4, or 7. The answer is x plus 3 times x plus 4. Using FOIL to check the answer we get, first terms, x times x equals x squared. Outside terms, x times 4 equals 4x. Inside terms, 3 times x equals 3x. Last terms, 3 times 4 equals 12. The middle term is correct. 4x plus 3x equals 7x. Another example. Factor the previous example with a negative middle term. X squared minus 7x plus 12. Answer, x minus 3 times x minus 4. Why? Because negative 3 times negative 4 equals positive 12, and negative 3x plus negative 4x equals negative 7x. Another example. Factor y squared plus y minus 20. Determine which two integers, if multiplied, give a product of negative 20, and if subtracted, a difference of 1. Possible factors: negative 1 times 20, negative 2 times 10, negative 4 times 5. Only the difference of 5 minus 4 equals 1 fits. The answer, y minus 4 times y plus 5. By now, we can come up with a way to tell when to add, when to subtract. Whether we add or subtract to form the two binomials is determined by the sign of the last term. If the sign of the last term is positive, the factors of the products of the last terms are added. If the sign of the last term is negative, the factors of the product of the last terms are subtracted. For example, factor y squared minus 5y minus 6. Determine which two integers give a product of negative 6 and a difference of negative 5. Possible factors: negative 6 times 1, negative 2 times 3. Only the difference negative 6 positive 1 equals negative 5 fits. The answer, y minus 6 times y plus 1. One more example. Factor y squared minus 11y plus 18. Determine which two integers give a product of 18 and a sum of negative 11. Possible factors: negative 18 times negative 1, negative 2 times negative 9, negative 3 times negative 6. Only the sum of negative 2 minus 9 equals negative 11 fits. The answer, y minus 9 times y minus 2.